Today we are going to be talking about multiplying and dividing these radicals. Basically, we're doing the exact same thing we were doing last time. The only real difference at all is that now we're going to start out by multiplying or dividing and then combining stuff together. The multiplying one, I think, is actually super easy because it's just sort of doing the same thing, just again. So let's start out with a couple real simple ones. We're starting out with the square root of 5n cubed times the square root of 25n. Alright, before I forget, the first thing that is super duper important when you're doing these is to remember that they have to be the same type of radical in order to work together. If they're not the same type of radical, like you see how these are both square roots, the indexes here are both 2, right? And we know it's 2 because that's what they are. They're a square root. Since they're both index of 2 roots, we can go ahead and continue. The thing is, I know for a fact on MathXL there's at least one problem where they're going to give you like a cube root and a fourth root, and you're going to be like, well, what do I do? And the answer is nothing, because you can't. There's nothing you can do to combine those. You can do each of them separately from each other, but you can't combine them. They have to have the same radical in order to combine. All right? So, what are we going to do here? First thing we're going to do is we're going to combine the insides. We've got a 5 and we've got a 25. So in our combined square root, that's going to give us 125. We got here n cubed, and here we got n to the first power, because it's just an n, so that's n to the fourth power, because 3 plus 1 is 4. Alright, now that we've done this, everything else is exactly the same as what we did on Monday. You're going to break down the 125. And, I'm going to break it down like this. But if you think of a different way to break it down, you can do that. Remember, this is a square root, so we need to pull out pairs with 2. And we got this 1 by itself. So we got a 5 on the outside. And we got a 5 on the inside. Remember, this one comes here. And then this one comes here. And then with the letters, n to the fourth is what we're working with, and we're trying to square root it. So 4 divided by 2 equals 2, remainder 0, which means that there are 2 on the outside and none on the inside. And so look at what we have left. We've got this thing right here and this thing right here. So when we combine all of our terms, the 5n squared is on the outside, and the radical 5 is on the inside. And this right here is our final answer. Alright, so the next one is 2 times the fourth root, fourth root of 50b times the fourth root of 100b to the 5th. Now, a couple things. Remember, if it's just b by itself, that's b to the 1. So we got 1 over there. And then you've got this extra thing on the outside already, right? This thing right here, that 2 is already on the outside. So make sure that you don't forget about it. We can basically ignore it till the end if you want, but we can also sort of combine it in as we go. It's basically up to you. What would you prefer? But we're going to do the same thing we did before. We're going to multiply everything together. So we got this 2 on the outside, and we got this 4th root. The numbers 50 times 100 is 5,000. And then we got a 5 b's and a 1b, so that is 5 plus 1 is 6. And then we have to break down this 5,000. So let's do that. Now again, does it matter how you break it up? No. If you're looking at 5,000 and you're paralyzed by, I've got so many different ways I could do this, I don't know how, or I don't know what that's supposed to be. Just go back to what the numbers were before. You got a 50 and 100. Just break it back down to 50 and 100 so that you don't have to think so hard. And then you could be like 5 and 10, 2 and 5, and then 100. You can make 10 and 10, and both of these are 2 and 5. If you're ever sitting there thinking, gosh, there's so many numbers, what if I forget something? What if I don't know how to pair them up when they're like this? Write them out. Put them in order. I got 1, 2, 3. I got 3 2s. And you can do this for the other stuff too. And I got 4 5s, right? So I want to figure out how many come out when I'm doing a 4th root. Be careful. Make sure you know what type of root you're working with. So let's take a look at the 2s. Do you see how I only have 3 2s? There are only 3 2s. So can I circle 4 2s? No. So I'm not going to circle these because there's not 4 of them. Leave those alone. But if you look at the 5s, you see I've got 1, 2, 3, 4 of those. I can make a 4 of a kind right here. And so on the outside is going to come a 5. And on the inside of this 4th root goes all 3 of these 2s. 2 times 2 times 2 leaves us with 8. Remember that 4 5s coming out, that's the same thing as us breaking this down, this 5,000 down into 625 times 8, and recognizing that, hey, the 4th root of 625 is exactly 5, and that 4th root of 8 I can't do. You can just leave that alone. See, either way I get the same thing, right? I'm not going to tell you what the easiest way is to lay this all out so that you understand what you're doing and how you feel, but both of these ways work for me. Either way, see how I got the same thing? So we did that. Now we can do the letters. So we got b to the 6, and I need to divide that by 4, right? Because it's a 4th root. 6 divided by 4 gives us 1, remainder 2. So once again, this is how many are on the outside. And then this is how many are on the inside. So now I've got my numbers. Now I've got my letters. And then don't forget I had this 2 out here to begin with. Don't lose it. So we got a 2 outside and a 5 outside and a b outside. So that's 10b. And then what's on the inside? The 4th root of 8b squared. Alrighty. Let's do a bunch more. Alright? We've got lots and lots and lots to do. Let's do... I'm going to skip down to number 11. And we've got the cube root of 4x to the fourth. And we got the cube root of 4x. Now, some of you might be saying, but Mr. Webster, you spent all that time moving it all together. Why not just break down each one separately? Well, sure, you can do that, and sometimes you'll get stuff out. But the problem is, if you were to put it all together afterwards, with all the stuff that you couldn't pull out, then you have to check all that again, because what if now there's enough on the inside to pull out again? So my recommendation is always to put it all together first. Make this 16, and again that's x to the 1 up here. 4 and 1 make x to the 5th. And don't forget this is a cube root. Don't forget that on MathXL they're going to have two different buttons. One of the buttons is for a square root, and the other button is for when it's not a square root, when you have to have an index up in here. Make sure that you are clicking the right button. A really common mistake that I run into as people are like, well, it's not letting me get the right answer, is that they're just sort of doing any old thing with it. All right, let's go ahead and break down 16 the same way. However you like. 2 and 8, 2 and 4, 2 and 2. And remember, I'm looking for cubes. That means I'm looking for 3 of a kind. Well, I've got 1, 2, 3, 4 2s. I can only circle 3 of them, though. Make a 3 of a kind, and then this one's left all by its lonesome. This 2 comes out, and this lonesome 2 has to stay in the cube root. Let's do the same thing with this x to the 5th. I gotta divide by 3. And that gives us 1, remainder 2. So once again, look what I get. I get 1 on the outside. And on the inside of the cube root, I have 2 left. So now, combining all my stuff, double checking. There was no numbers on the outside to start with, so I don't have to worry about that. See how it was just nothing out here on the outside to begin with. 2x. And then on the inside of the radical, 3 for the root, 2x squared. And that is your final answer. So let's go ahead and move on. So we did multiplication. Now what we're going to do is division. So what I want to tell you is when you're doing this, when you're doing these problems, make sure you do a bunch of simplifying first so you've got less work to do later. All right? So look, here's what we do. This is going to look kind of ugly to start with, but it cleans up real nice. So look at what we got. We got this thing. On top, and this thing on bottom. Alright, now, like I said, it is super important for you to simplify what you can first so that you have less work to do later. What do I mean? Look, you can simplify on the outside. You got the 5 over 3. You can't simplify that. Ain't nothing to simplify. You can simplify the 8 and the 36. Well, there's stuff to simplify there. I can pull out a 4 from both of these. So left up on top is 2. Left down on bottom, 36 divided by 4 is 9. And then the same thing with the x squared and the x cubed. Look, see there's 2 x's on top and 3 x's on bottom. If it helps, think about it like there's xx and xxx here. 1x cancels, 2x cancels, right? So look at what's left over once we've simplified our big old fraction. We got 2 left from the number on top, and on bottom we've got 9x. All right, now what's going to be really helpful is if we break this down, because we need to rationalize this denominator. We're not allowed to have a radical in the bottom. So what's going to be really helpful is on the inside here, let's break down everything. We got an x, that's x to the 1, and we got a 9, which breaks down to 3 and 3, right? Now, here's what I like to do, because I have to multiply something into this radical to pop this radical and let everything out. And I have to do the same thing to the top. So some kind of fourth root has got to get multiplied to the top and the bottom. Now, let's think about this. I've got 2 3's, but in order to get out of here, I need 4. So what I'm going to do is I'm going to put 2 3's here, 3 times 3. And I got 1x, but I need 4 to get out. So if I've got 1 here, I need 3 more to get out. Now you know that's 9x cubed. You don't have to write it down like this if you don't want to, but I want to show you, hey look, I've got now 1, 2, 3, 4, 3's on bottom. I've got 1, 2, 3, 4 x's on bottom. And remember, if I do that on the bottom, I have to do it on the top. I'm going to write it all simplified up on top. 3 and 3 is 9, right? X is x cubed. And now look what happens. This part doesn't change. But on bottom, we have 4 3's, so out pops the 3. And we've got 4 x's, so out pops an x. And on top, look at what we got. We got 2 and 9 is 18. And then bring those 3 x's in there. Now, here's the thing. If we did this right, 9 times out of 10, this top radical doesn't need anything more to be done to it. We simplified all the stuff in common, so there's nothing in common between the top and the bottom anymore. All we added was stuff that is in common with the bottom, so nothing better be in common with the top, which means that this radical on top can't break down anyway. Now, if you didn't simplify it all the way down, or you didn't do whatever, then maybe there's some stuff left over. Double check to make sure. But usually, this fourth root is all done. All you have to do is look at all the numbers outside, make sure everything is all nice and simplified on top and on bottom. 3 times 3 is 9. And 5 over 9 doesn't simplify. There's no x's on the outside, so we don't have to worry about that. And this right here is completely simplified. All done. Okay, let's do a ton more of these. Let's keep on going with it because we want to make sure that we know all the stuff going on. Let's do, okay, look at number 22. That one starts out real ugly looking, and it's going to end up really simple looking, which is really cool, I think. That it can go from being so ugly and have all the things cancel out and then end up so simple looking. All right, what do we got? 15x cubed y squared. Okay, cool. So, let's break it down. The 3 and the 2, can't do any simplifying there. The 20 and the 15, we totally can, right? There's a 5 in each of them, so we can make that a 4, and we can make that a 3. On top, we've got 1x. On bottom, we've got 3 x's. So the 1x cancels out with one of these, leaving 2 on the bottom. On top, we've got 4 y's. On bottom, we've got 2 y's. So when all is said and done, we've just got 2 left over on top. So let's rewrite this all simple like. 4y squared on top. And 2 times 3x squared on bottom. All right, here's what's really cool about this. Again, break it down so you can see what's going on. You got a 3, got an x and an x on bottom, right? How many more 3's do I need to make 2 3's up in here? Well, clearly I need 1, right? There's 1 here. I need 1 more. How many x's do I need to make a pair of x's? The answer is I don't, right? There's already 2 x's here. I don't need to do anything with that. That's already going to be fine. That's awesome. All right, now, since there's a 3 on bottom, we got to put a 3 and a radical on top. So let's go ahead. We've got 3. And now all the stuff on the inside is saturated. It pops out a 3 and an x. And on top, look, we got a 4, a y squared, and a 3. So 12y squared. And then now, as far as I'm concerned, this top here, see what you can do, right? Take a look. You see how there's a 12 in there and a y squared in there? Yeah, this is what I was talking about. Maybe there's something still in there from the top that we didn't simplify out. Right? 12, what does that break down to? That breaks down to 4 and 3. And that y squared, when you divide 2 by 1, you get 1. So look, I'm going to pull out a 2. I'm going to pull out a y. And just the number 3 is going to be left up in here. And then the 2 and the 3x on bottom. And let's simplify what we can outside now. See how there's a 3 here and a 3 here. See how there's a 2 here and a 2 here. Let's get rid of those. And then this would be how I would personally write my final answer. All right? I want to do a couple more. Like I said, we've got a lot of time. And this is the only other thing that we actually have to do, which is great. All right, so let's do number 28. Let's do number 28. I like that one. So there's not going to be anything on the outside this time. It's all on the inside. 4a cubed, b to the fourth, over 3a squared b squared. Now, here's another option you have, because I know maybe some of you were thinking, but I don't want to have to break that one down again. Can't I just break it all down in the beginning and see what I get? Yeah. Let's see what we can do here. Let's do the numbers. 4 and 3, nothing in common. So there's just going to be a 4 here and a 3 here. A cubed on top, a squared on bottom. So 3 on top, 2 on bottom. There's just going to be 1 left on top. B to the fourth over b squared. There's 4 on top and there's 2 on bottom. So when we're left over, there's going to be 2 on top. And that's all this turns into. 4a to the 1 b squared over 3 and all those radicals. Here's the thing. There is stuff on top that you can take care of right now before you even bother rationalizing the denominator. And you can choose to do that right now, right? The 4, what's the square root of 4? Isn't it just 2? B squared. What's the square root of b squared? Isn't that just b? Now the a doesn't have anything, so we'll leave it inside. And then that radical 3 doesn't have anything, so we'll leave that inside. So now look at what happened. All the stuff on top and all the stuff on bottom got simplified as far as it could be. The only step we have left is to rationalize the denominator. Now this is a square root. Remember, we need 2 of a kind. We only have 1 3. So let's put 1 3 down here. Let's put 1 3 up here. That'll make those radicals pop, leaving just a 3 on the bottom, a 2b on the outside left over, and on the inside of the radical here will be a 3a. And since we simplified our fraction and we broke down the radical in advance, we know that there's nothing left to do inside this radical now. So this already we know is our final answer right now. All right. Let's do, I want to do another one that's not a square root, because those are, they always feel heavier. All right. What do we got? We got the cube root of 5n over 2 times the cube root of negative 25n squared. Okay, so we talked about this on Monday, but if you've got a situation where there's a negative sign here, and it's an odd power, it's an odd root, bring that negative sign right out. Start off, before you even begin this problem, bring that negative sign right out here because it's a cube root. Before we even bother doing any sort of simplifying, you could even take another step, write it out, like this. All right, like that. Now, you go through, and now let's simplify our fraction. Take a look. Got a 5 on top and a 25 on bottom. So look, the 5 on top cancels with the 25 on bottom, leaving 5 on bottom. The n on top cancels with the n squared on bottom, leaving just 1 n there. So all the stuff in the top radical went away. Hey, that's cool. So look at what we got just on top is just the number 1, because the whole radical canceled out. On bottom, we got that -2, and then we got the cube root of 5n. So now we're going to do the exact same thing that we did before. How many more 5s do I need? Well, it's a cube root. I've got 1 5, so I need 2 more. Put a 5 and a 5. So I get 5, 5, 5. That's 5. That's all of them. 3 5s. And I got 1 n here, so I need 2 more n's to make 3 on the bottom. And if I do it to the bottom, gotta do it to the top. And again, if you want to write this as 25n squared right away, you can, because that's what it's going to be on top. 25n squared on top. And then a 5 pops out, an n pops out. And we are left with the cube root of 25n squared over -10n. And this negative sign, some people will pull it out to the very front. It's fine down here. This is just as correct as anything else.